Solution to problem 17 on the layout strategies chapter. This question entails a assembly line that manufactures one-person sailboats. Um, Basically, the big numbers we need to realize from this is they have this area for 200 minutes per day to make these one-person sailboats, and they have to make 60 boats. First, what it asks is to draw the precedence diagram and assign tasks. So here's the diagram. First thing we should look at is this table, which entails all of the information we're going to need. So what I did first was calculate the cycle time so that we can understand how long each workstation, or like how long the product should be in each workstation. So cycle time, the equation is production time available divided by the units required per day. So these are the numbers I just went over. We have it for 200 minutes, and then we have to make 60 units per day. So that comes out to 3.33 minutes. And so all we have to do for this precedence diagram is realize that these have to be under 3 minutes. And so this is all marked up with how long each section or job will take. Each task, I guess, is how you would phrase it. So we want to keep these under 3 minutes, and this is just the easiest way to do it. Obviously, we know since E is 3 minutes exactly, that's going to be by itself, and then we just have to divvy up the other ones and stay kind of in this line so they're not going back and forth. So they're all under 3 minutes. There are obviously some that are 2 minutes, so there's going to be some idle time. We'll talk about that a little bit later. So yeah, this is just the diagram that I made. Pretty simple. Next, we're going to move on to the efficiency of the assembly line. So efficiency is just like the total task times, which is going to be 13 minutes. That's just adding up these numbers. That's going to come out to 13 minutes. Divided by the number of workstations, which is 5. It talks about that in the question, using 5 workstations. So that's going to be 5 times 3.33, because that's the cycle time. So that's going to come out, this bottom section is going to be 16.65. So 13 divided by 16.65, you're going to get 0.78, or just 78%, which is somewhat low, but we kind of expected that when you look at the precedence diagram. So now we're going to look at what the theoretical minimum could be. So the original question asked us to do it using 5 workstations. We're going to see if there's a more efficient way to do that, or what the minimum will be. So this is pretty simple. You're just going to do the total task time, that 13 minutes, which we've already done, divided by the cycle time, 3.33. That's going to come out to 3.9, but you are supposed to round up to the nearest whole number, so 4 workstations. So it could be done with less workstations than the 5 originally asked for in the problem. And finally, what is the idle time per boat produced? Idle time is just the actual number of workstations times the larger cycle time, which is 3. We've made sure of that. The actual number of workstations is 5. And then that's going to be minus the total task time, so 13. 15 minus 13 is going to get you 2 minutes, so there's 2 minutes of idle time, which would appear to be correct because we have 3 minutes, 3 minutes, 3 minutes. Then we have 2 minutes, 2 minutes. There's 2 of those. And yeah, not too difficult of a question, but I believe everything here is correct. If not, I would love